Okay, guys. Okay. In previous class, we talked about how we can transform this space relationship diagram into the real diagram, real layout. And there are two approaches: improvement approach and creation approach. In improvement approach, we discussed about two-way, pairwise, and some optimization based on the grid. And for the creation process, we talked about the guillotine method and space stealing curve. And there is many more. Okay, the very straightforward way to calculate it is construct a optimization formulation. For example, like this. Based on this kind of space requirement diagram, we first can assume that a space can be defined as 4 points if the space is rectangular. Right? If you know this 4 number, you can plot this space on this layout. Right? So, for 1, 2, 3, 4, 5 different space, department, you need 4 times 5 variables, right? And if you know this one, you can automatically calculate the area. x2 minus x1 times y2 minus y1. And this space requirement and this area of each space should be equal to the required spaces for each department, which comes as one constraint of that space. Also, things like that. Since we define the space with this x1, x2, y1, y2 method, x2 should be always greater than x1. If the order is changed, the area calculation formulation doesn't work anymore. So x2 should be greater than x1, y2 should be greater than y1 if we keep this is our coordinate system. There comes another constraint. Okay? And if you define x1, y1, x2, y2, you can automatically calculate the centroid of this. It's half of the x1 and x2 and half of the y1 and y2. That's the automatic of the centroid. Okay, so if you have the lower left corner coordinate and upper left corner coordinate and lower right corner coordinate for each of the space, and their constraint, x1 should be less than x2, y1 should be y2, and their area requirement as a constraint, and overlapping constraint. For example, if this is a department number 2, this could not happen, right? Because if that's the case, department areas overlap to each other. But by putting some kind of constraint, you can make sure this overlapping will not happen, right? If this is x3, y3, x4, y4, then you can make some kind of a constraint. If y3 is less than y2 and greater than y1, x2, x3 should be greater than x2, or and the like, and the like, and the like. Okay? Based on this mathematical reasoning, you can clearly write the optimization formulation. Your design variable is lower upper right, upper left corner coordinate and lower right core coordinate for each of the department. So if you have a 10 department to arrange, you need 40 design variable and all the related constraint. And eventually you can construct a optimization thing. Mathematically, this is really straightforward and strong. However, if the number of constraints, as this kind of optimization formulation is like, if the number of design variable increase and the number of constraints increase, the chance of finding the optimal solution is getting lower and lower. So for the very limited number of department, you can easily construct it. And actually it will be really easy for classroom size example. Any question about this full optimization method? Okay, let me ask a question. What would be the limitation of this approach? First one I mentioned, if the problem size getting larger, the solution time becomes exponentially large. And what else? Oh yeah, the superposition is prevented by applying constraint. So thing is, you're right. Because of this superposition, the optimal solution is very hard to get. And the next thing we can think of is, okay, for the rectangular shape, we can handle it. However, if it's not rectangle, sometimes there has to be L shape or T shaped spaces, but very hard to construct those kind of spaces. And also, think of this kind of thing. There are obstacles. This kind of obstacle can be translated into some kind of constraint. For example, from here to there, no x and y cannot be defined. We can put a constraint like this because, narrowing down the design spaces. However, as the number of constraints increases, this optimization is really hard to solve. That's it. But it's a mathematically very strong and straightforward way to create a new layout from scratch. Question? If the layout is rectangular and we only have 3 or 5 departments, I think this is the best way to do that, right? You can done. Yeah.
Why are we always considering the rectangular shape of the departments? Even in that layout or in the shaping curve, we always consider the rectangular shape. Why are we considering another shape, like circular department?
Oh, very nice to mention that. You know, arranging things around. Basically, arranging things around. One of the implicit objective is we want to minimize wasted spaces, right? But usually, random shape of the rand, if you put circular department, we cannot avoid some of the wasted area, right? I mean, if you stick to the rectangular one, you can virtually eliminate all the wasted area, basically.
So if we needed only one department as circular, if the
Oh, okay.
then
very good, very good. There is some ship, U.S. Navy ship, propelled by the nuclear reactor, right? And in their ship, nuclear reactor is circular, cylindrical. So at the middle of the ship, reactor is located like that. And this is really, really, really heavy and dangerous and important thing. You cannot modify its location. You have to arrange the space around this one. But this is circular, as you mentioned. But if we stick to the rectangular grid, how can we well arrange our spaces? If this is the side of this circular shape, and if we stick to this kind of rectangular grid, then we cannot use this kind of spaces. Right answer. What would be the alternative then? Grid is the most simple and straightforward grid is the rectangular grid, but the grid don't have to be rectangular grid. So this is center of the reactor, and let's draw the cylindrical circular grid. Sorry. Anyway, it should be something like this. Okay? Thing is, the grid don't have to be rectilinear. Any type of grid will work. However, in this chip, other than this area, rectilinear grid is best. So there is some kind of transient grid region is required. But cleverly, you can make relevant grid out of it. Here, same thing. Okay. Having drawn this grid, can you apply the exactly same thing with this one? Yeah, why not? Can you draw the space filling curve? Why not? We can do it, right? However, have to be very careful in calculating your D sub I and J. The calculation method is a little bit different. In rectilinear, if you only have the centroid and centroid, you can easily subtract x minus x, y minus y, and that's it. But in here, you have to do some kind of sine function or cosine function and the like. But except that, everything is exactly same. Not only the circular grid, but also the triangular grid is also good. For example, if your factory shape is something like this, then make the rectilinear grid here and make the triangle here. This is sometimes not so good. So people will usually do this. Rectilinear here, but this region, you know what I mean? It resembles rectilinear, but it's not rectangular. But however, this will work without any problem. Space filling curve, this method as well, that method as well, no problem at all. And the very basic reason is that usually we arrange factory inside of the building, and usually most of the building are rectangular. Why? I don't know. Number of circular building versus number of rectangular building. Well, okay. Any question so far? There are some other way to arrange things. This is a little bit different from this approach, but let's explain a little bit. Have you ever have you ever heard of this agent system, software agent system, artificial intelligent agent? Nope. Okay. Okay. Have you ever heard about software engineering or object-oriented analysis or something like that? You know what the class is in C++ or Java? Okay. You know, in software engineering, people just try to write the code, do the sequential thing, right? But sometimes there are redundancy. Doing from the start to end, do it, but sometimes this chunk of the code are required in many times, even though this module is identical. So people have thought about function. So make this repetitive module as an external function, and when you need that, you just call this function and do the same thing again and again and again. Okay? Functional programming. You heavily use functions. But the software getting more complex and complex, and input and output can be messy. You know, what is code and what is output, all this can be messy. So people try to make something more similar to some real life module like TV or VTR or something like that. All you have to do is know how to use the interfaces and what would be the desired result. So they made something called object. Just like a function. It has some method, but it has its own data with it. So the external code can only call this object like we push the button of the TV without understanding the inner mechanism of TV or VTR. All we have to know is what's the interface, what we supposed to do to use it, and what would be the expected output when we do something like this. Those things are called object. And analyze your software system into group of the object is object-oriented analysis. That's what we call usually the advent of the C++ or Java or something like that. Okay, from function, object, next thing is agent. Object system like a TV are just sitting there when people waiting for others' messages. In the code, when we need something for the object, we call that object and passing messages, do something, turn the power on, change the channel or something like that. If we pass the message, then it will do the job and it will return the message, job completed or something like that. That's the object. Agent system goes a little bit further. It keeps doing something and it actively interacts with environment. Okay? That's it. Nothing more than that. Anyway, this is not computer software program course. So what I'd like to introduce here is the basic utilizing this kind of basic understanding of software agent in factory layout design. First one is you have to define your department, the key element of the layout, as one agent, or if the object is more convenient, you can call it object. So out of this ABCDE department, make space ABCDE as an object, and this object, department A object, has its own title, department A, required space, right? And its centroid location. Okay? That's it. Right? Okay. And thing is like this. By the way, we still need grid. Okay? And we still need some kind of main program. Initially, as I mentioned in previous class, the initial location of each of the department should be set by the program. How? Well, we have this space relationship diagram, and based on this topology, we can automatically allocate the initial point of that onto the grid. Can you do that? Yeah. If I were you, I'd like to do this. First of all, we know this, and each department has requirement space, centroid location, and other relevant information. And based on this, in this diagram, we each calculated the centroid of this circle, right? Based on some coordinate system, right? And the smallest possible x and largest possible x, smallest possible y, largest possible y, we can make it as our design space in this space relationship diagram. Okay? And this, we have the size of the rectilinear thing, right? And this is a real space. However, we can easily construct the bounding box. Do you know what the bounding box is? The smallest possible rectangle that can keep this shape inside. Okay? Let's map this one into, here we calculated, by the way, you need some padding here and there. And can you map this rectangular into your bounding box location? Can you do that? Right. And this one could be somewhere here. That one could be somewhere here. Maybe here, here. The location is not 100% aligned to this grid, but you can round it up and do some mathematical thing. You can end up with the initial grid. Question so far? Question? Well, sometimes it could happen. The thing is, well, your initial location are mapped here, outside of the boundary. Then you just move it to the nearest possible position. Same thing holds here. If your initial cell coincide with the location of the obstacle, do the same thing. Move x or y, which is the shortest. You do the move and make that the initial starting point. Okay? Questions so far? Okay, good. Okay, the next thing is make things grow. Okay? Number 0 is gridding. Grid generation. The size of the grid, it cannot be a square. Don't have to be a square, but it also don't have to be rectilinear. But anyway, square is best. If it's not possible, rectangular is best. Okay, but the size should be cleverly chosen to cover obstacle and the shape very well. Okay, and the space requirement should be transformed into the number of required cells for each of the spaces. But anyway, based on step 0, you cover that. Based on step number 1, you determine the initial location, right? And since each space has its own number of grids requirement, and it knows how many more grid should I grow to, right? Okay? Question? Okay. Okay. Now it's time to let the space, department object to grow. Okay? I will suggest first perimeter direction grow algorithm. Thing is, it's the simplest possible thing I can think of. If this is your initial seeding location, first you have to do check. This is north, south, west, east. Check all the direction and check if there are any obstacles or boundary. North, south, west, east. Okay? If there is no boundary or obstacles, you are supposed to you checked it and there is no boundaries or obstacles, then you grow to this. Okay? Question? What if in some direction there is an obstacle or boundary? So, for example, check it. Well, there is a boundary here. Then you have to do is accept that direction, you grow. If you have a 2, then accept that direction, you grow. Any question? Checking first is very important. With already there, obstacles and boundaries. It's like a computer game, in some computer game, NPC, non-playable character, have you ever been to online game, computer game? There is a player, so we can do, but there is some shop owner or something which is not playable character. These obstacle and boundaries are something called non-playable character. Very similar. It's just static thing. Since it's a static, we can easily take this. Okay? But sometimes spaces can conflict to each other. It's a player and also player. Okay? Things like that. Now you grew this much, and this one grew this much. I don't know, maybe. Okay? And this space wants to grow one more thing, here and there, right? And this thing wants to grow 1, 2, 3 direction, right? Okay, checking here and here, boundaries, so no growth, but here, nothing, okay. Here, have to check this direction, this space's potential growth area are overlapping this space's potential growth area, grid by grid. Then, there must be something called conflict resolution algorithm. And most simple thing is this. You know, the satisfactory level is higher and satisfactory level is low. This one have the priority. What's the satisfactory level? Well, the thing is like that. Required number of grid cell is 20, and now its growth has grown to 18. So it has 2 more to go. But requirement is 100, and now it's just 20. So it has to grow 80 more. Satisfactory level is much lower than this. Because it's a low satisfactory, give this priority to this. That's it. Conflict can be resolutive, okay? If you have conflict, you have the priority and you grow. End of the story. Okay? What if those two has the exactly same satisfactory level? I don't know, maybe if the department with the highest f sub ij can be higher priority, or department with the many other number of relationship, department with most relationship with other department has the priority, and there must be some other rules we can apply, right? Anyone? Any question? So by doing that, we can specifically identify the possible growth cells and others. Okay? And you repeat this one until there is no unarranged space. Until all the spaces are filled, you can keep doing this, and that's it. Question? Yep.
So why does the in the question that you told there until all the spaces are filled? Shouldn't if there are unused spaces, but all the departments are grown into.
Oh, good thing. So your question is, the summary of all the space requirement is 200, but the grid is 220, so there must be 20 left unused space. But why? It's up to you. If I were you, look into the problem, and if this 20 is really unnecessary, I will previously mark those 20 unnecessary space as obstacle. If you really want to leave those 20 spaces. And if not, that's not the case, then include everything and let them grow. Let them overgrow. And anyway, once you make it, you can still have the chance to massage it. The thing is like that. This is really simple. It's not optimized one, by the way. It's just let them grow. Okay? If we still put optimization technique in here, but that will make the problem very difficult. So I'd like to ask you to just implement this growth algorithm to create unoptimized initial layout and then massage it by pairwise thing or something like that. So, question, can you implement this kind of algorithm? So things like this. Let me reiterate. Let's say this is your current space, and check your north, south, west, east potential cell. These are your potential growth area. Okay? And sometimes if this is your boundary, and you can identify you already touched a boundary because you don't have this. Okay, by the way, this is your potential growth area, and if there is no other spaces competing for this, then you can just grow, right? So next step, your space will be like this. Okay. And the next step, your potential growth cell is this. And the other spaces, potential growth that there is some union, common cells here. Then compare the satisfactory level. And if this is one higher, then give that intersected potential growth cell to this guy and eliminate them in my potential growth area. Okay, then grow it. You keep doing it until all the spaces are arranged. There are little variation, by the way. Variation is like that. I just mentioned that all perimeter direction at the same time, but this could be an answer. But if implementing this is quite difficult, you can take turns. North first, then south, and then west and east. One direction at a time. It's up to you. Okay? Let's take a 10-minute break at this point. Okay, guys. I said that including this growth algorithm with the optimization thing is a little complex, but I will give you a hint, by the way. Very simple. If this is your space, current space, this is your centroid. You can easily calculate, right? Right? And based on this d sub I and j, you can calculate the cost of the layout instantly. Okay? Things like that. First, if this is your potential growth area, if you grow into this area, your centroid will change a little bit like this. Okay? Based on that, calculate the cost. And if the cost decrease, grow it. If the cost increase, do not grow. Got the idea? So, thing is like that. From the initial seeding cell location, you constantly grow to the direction where the cost becomes less and less. Okay, question, comments? Okay. Okay, creating a layout and designing a layout is one thing. The next thing is we have to validate our layout is really good or not. I think the most effective way to do that is run the discrete event simulation. Is it coming? Very slowly. Okay, guys, have you ever heard about discrete event simulation? Okay. Then I will show some YouTube video. This is, there are numerous other software to do the discrete event simulation, and this is one of them, Delmia's Quest. And this is it. This is discrete event simulation. They simulate the factory as it is. Well, however, it depends on the level of detail you'd like to capture during the model. But things like this, it sees the system, I mean our manufacturing system, as a whole system, has some state variable, and there is an event. The definition of event is something that can change the state variable of the system. That is the event. By simulating those events, the system's state is constantly changing, and if we keep track of every changes, then it could mimic the real world experimentation. That's the very basic idea of discrete event simulation. The goodness of the discrete event simulation, well, it's really nice to validate things. You know, it resembles real life. It can capture, depending on the level of detail you'd like to model, but it can capture every possible detail. We sometimes intentionally neglect in mathematical modeling. Think of the Nussbaum model or QRR model. We assume things to make the problem simpler and simple enough to solve. Well, this kind of analytical approach gives us some insight about the trends or behavior of the manufacturing system, but that's it. It does not mimic this level of detail of actual behavior of the discrete manufacturing system. Okay, looks very realistic, and it's a very nice tool to persuade people. For example, like this. Well, if we are the engineer, layout engineer, and our job is satisfy the owner of this factory, well, based on your data, the optimal layout is like this. It's not that strong persuasion. But if we transform this layout into this one and do the all working going in just like this, then I think this is automatic persuasion to the customer, right? By the way, this video is created by FlexSims, another type of discrete event simulation software. Okay. Any question about discrete event simulation? Okay. Good thing is, very good tool to verify and validate. Automatic persuasion. You don't have to show some very complex diagram or equation to show that your result is real or not. You can just show this video, even though the audience is not engineers, it's a general public. No problem at all. Very good tool to persuade and show the results. Okay, in making a automobile assembly line requires decent amount of money. So everything should be considered before you actually build the things. Nice tool is to build virtual factory, and check that the factory will work as we designed. This discrete event simulation is very nice tool to do that. If you combine this discrete event simulation with some kind of robot programming, then it will make your job much easier. You know, program your robot in virtual world, and many software has the PLC controller, and it automatically transform the robot programming code back to the real life robot. Okay? Question about this discrete event simulation? Okay, and I will explain academically how this discrete event simulation works. And before doing that, I have to define things first. System is a collection of entities. Okay? And model is an abstract representation of a system. Okay? What we just saw is what? It's a model. Virtual factory is a model. Yes. System here is the real factory. Abstraction of real thing is model. So our discrete event system is a model of the real system. Well, if the target system is the virtual system, then, when you abstract once, it could be a system model, and if you represent the model itself with more abstraction, then it called meta model. Okay, things like this. Okay, the system is a collection of entities, people, machine, material, and all the things that interact together over time to accomplish one or more goals. Very similar to the definition of manufacturing system. Model is an abstract representation of a system. Okay? And system has its state, collection of variables that contain all the information necessary to describe the system at any time. It's also dependent on the level of detail you'd like to capture. For example, at a higher level of detail, for example, the Daejeon city's subway system, at a higher level, all we wanted to know is the location of subway along the line. That would be enough. At this time, the Daejeon subway system is one-dimensional linear thing, and at current time, the subway is here and here and here, moving this direction, and there, moving this direction. That is just enough information for the top level system, right? Okay. Location of the system, for example, can be defined in many other types. For example, if this is x equals 0 and x is equal to L, you can explain the current location and velocity as a system variable. And if there are six subway trains, then 6 variables of location and 6 variables of velocity that will explain overall system. It's not anymore, not less than that. Just enough amount of the system state. But by the way, the system states are not uniquely defined based on the description. For example, location of the subway can be described in X location from 0 to L. But location of the train can be defined based on the stations. The train number 1 is at Tambang station, or between Tambang and City Hall station. Okay? Anyway, the system can be described as the system state. Any question? Okay. If train moves, it changes the system state. Location changes, velocity changes. Okay. We have to keep asking, is this really enough information to describe our system? Well, it depends on the level of detail we want to cover. Abstraction. Transform the real system into the model. Abstraction means we keep focusing on what we are interested in and ignore the others, right? That's the abstraction. So this is nice abstraction, but if your abstraction level is much more deeper, much more close to the real world system, the system state and system variable could be different. If you are the operator of the one train inside of this subway system, the system should be different. You have to know your actual location and speed. It's the same thing as the higher level abstraction, but you have to know the door close or open state, and there must be many other things to consider. Your alignment with your door and the station's door, their station, many other system state could be included. Bottom line, everything depends on your level of abstraction, level of detail. But anyway, system should be 100% described based on this system state. Entity, any object or component in the system which requires an explicit representation in the model. I will explain in more detailed manner. Also, attribute and list. Entity is the actors inside of this model, and their property are called attributes. And list is the collection of associated entities, not randomly collected entity. Some logical fashion they are associated. Also, event is some event that changes the system state. As a train operator, door close is an event because it changes your system state. Door open state to door closed state. Event notice is a list of your event. You can predict what event will happen. For example, if you're the train operator, you stopped. Current state is that you stopped at the station, everything is perfectly aligned, and you hit the button, the door will open, but in some time after, the door will close because your plan are described as such. So in 3 minutes later, door will be closed. It's your future event, and it's an event notice at the same time. Okay, question? In the previous video clips, in several video clips, bottles are moving along the conveyor line, people are moving from one workstation to the other workstation. These things are pre-planned, okay, in logical manner. So, in every time, thing is not regenerated, but every event, thing is regenerated. Okay. Okay. There is something called event list of the event and activity. It's a time duration between event and event. There is something called a delay. Delay means the time, duration of time of some length, and which is not known until it ends. And it's a common translation of what we call delay. I'm supposed to close the door at this time, but something is blocking my event. People are continuously coming in, then my event of door close is delayed. Something like that. Clock is just clock. Okay. Time's up, so let's call it a day. But in the Wednesday class, we will keep talking about this discrete event simulation, and after that, TA will teach you about how to use the quest. Okay? Thank you.